In a small, domed nest woven from grass and spider webs, a female superb fairy wren is not just warming her eggs, she is teaching. She sings a soft, complex series of notes, a call that is unique to her. This isn't a general song for territory or mating. It is aimed directly at the unhatched life forms within the thin, speckled shells. To our ears, it might sound like a simple melody, but for the embryos developing inside, it is the most important lesson they will ever learn. It's a lesson taught through vibrations, carried through the shell into a developing brain that has never seen light. Inside the egg, an auditory system is coming online. Around day 10 of incubation, the chick's ears are functional enough to perceive sound. The mother's constant, repetitive song isn't just noise, it is data. This acoustic information is actively shaping neural pathways, creating a template in the chick's memory. This is a form of prenatal learning that is profoundly consequential. Unlike a human fetus learning the general cadence of a mother's voice, this avian embryo is memorizing a very specific acoustic key. A single, signature note embedded within the mother's song becomes ingrained in its mind. Once the chicks hatch, they are helpless, tiny, blind, and utterly dependent. Their survival hinges on convincing their parents to provide food. They do this by begging, a series of high-pitched calls. But a generic cry for food is not enough. Woven into their chirps must be the signature note they learned in the egg. This specific note is the password. The parents listen intently to their nestling's calls. If the password is correct, the chick receives a meal. If it's absent, it risks starvation. This entire system of vocal passwords exists for one primary reason: to combat a specific type of thief. The horsefield's bronze cuckoo is a brood parasite. The female cuckoo doesn't build her own nest. She finds a wren's nest, and in a moment when the parents are away, she lays a single egg that closely mimics the wren's own. The unsuspecting wren parents then incubate this foreign egg as if it were their own. The cuckoo's strategy is to outsource all the work of parenting. When the cuckoo chick hatches, it is often larger and more aggressive, pushing the wren's own eggs or chicks out of the nest. The cuckoo chick is a master of deception. Its begging calls can sound remarkably similar to those of the wren chicks it replaced. But it has a critical vulnerability. The cuckoo egg is laid after the wren has already begun incubating her own clutch. This means the cuckoo embryo misses the crucial learning period. It isn't there to hear the mother wren repeat her secret signature note over and over. It never gets the password. So when it hatches and begs for food, its call is a near-perfect forgery, but one that is missing the single most important element. When the parent wrens hear the begging calls from their nest, something feels wrong. The call is loud, insistent, but the password is not there. The acoustic key that identifies the chick as their own is absent. This triggers a brutal but evolutionarily necessary response. In a majority of cases studied by researchers like Diane Colombelli-Negrel, the parents abandon the nest entirely. They stop bringing food, leaving the parasitic cuckoo chick to starve. They sacrifice a single breeding attempt to avoid wasting resources on an imposter, ensuring their future reproductive success. This isn't an isolated trick developed by one bird species. It is a front line in a co-evolutionary arms race. The wrens evolve a defense, the vocal password, and the cuckoos are under immense pressure to crack it. Perhaps in the future, cuckoos will evolve to lay their eggs earlier, or their chicks will evolve an innate ability to guess the password. In response, the wrens would then need to evolve a more complex password, maybe one that changes with each clutch. This dynamic back and forth, known as the Red Queen hypothesis, is a driving force of evolution, where species must constantly adapt just to maintain their standing. The superb fairy wren isn't alone. Similar password systems have been discovered in other species, like the red-backed fairy wren, and even unrelated birds like some Australian grassfinches. Finding the same solution to the same problem in different species suggests that this form of vocal learning is a deeply ancient and effective strategy. It's a biological version of two-factor authentication that evolved millions of years before humans ever conceived of such a thing. The first factor is being in the nest. The second is knowing the family password, a password learned before you've even met the family.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.